This is for number 23 in Math 161 Practice Test 1. So 23 is asking, use the factor theorem to determine if the given binomial is a factor of f of x. So, we have x plus 1 is the first one that we are going to check. If it's a factor, if we divide, we're going to get a remainder of 0. I mean, you guys can do this two different ways. You can use the synthetic division, actually do the division, and see if the remainder comes out to be 0. Or we can use the factor theorem. We can actually plug in. We can actually do this. And I think I will do that because I have my Desmos up and everything. If the factor they want us to test is x plus 1. Oh, I'm sorry, you don't see what I'm writing on my pad. Let me bring this up. If that is the first thing that they want us to test, then what we should check is this. Check f of negative 1. Check and see if this is 0. If this is 0, x plus 1 is a factor. Okay? So let me go ahead and just, because for the previous problem, I had my Desmos scientific calculator up and ready. Let me go ahead and type in It's a struggle for me to show you every screen that I'm looking at. Alright, I'm going to go ahead and restart typing x to the 4th power. I'm plugging in negative 1. So make sure you draw parentheses around any of your negative numbers. So I'm doing negative 1 to the 4th power minus 6 times negative 1 raised to the 3rd power plus 3 times negative 1 squared plus 4 times negative 1 plus 12. Look, the function value, when I plugged in negative 1, came out to be 18. Okay, the one that we wanted to see was 0. If it comes out to be 0, that means negative 1 is a 0 and x plus 1 is a factor. But since the function value is not 0, what we can say about this problem is that x plus 1 is not a factor of f of x. Okay, next one. They want us to now test if the factor x minus 2 is a factor. Okay, we want to see if that's a factor. Well, what we can check is f of 2. We can plug in the potential 0. We can plug in 2 into the function and see if that gives us the function value of 0. If it does, we're going to say 2 is a 0 of this polynomial. Therefore, x minus 2 is a factor. So let's plug in 2 into the function. So what I will do is I'll be a little lazy over here. I will copy the line above. And I will just replace the negative 1, the previous x value that we tested, by 2. I kind of have a feeling this one will be a 0 because the first one wasn't. Look, it came out to be 0. So the function value is 0. So that means x minus 2 must be a factor. And that is how you can do the factor theorem problem. Would you like to see if that was right? That makes me happy. I hope you don't submit tests 40 times just to see if you got all 40 problems right each time. You know, I'm just doing this because I'm making these videos one problem at a time. That's why I'm doing this. What was the one that we just did, by the way? Was it number 23? Let's see if we got a check mark next to 23. Yes, we do. So we are doing good.